In order to be able to talk about statistics, we need to have some common language. And so the main point here is not necessarily to memorize these terms and whatnot, but just to know when we say these words, they have specific meanings and that we need to get into the practice of using them correctly. So we're just going to run through a lot of definitions here. It's not super exciting, but it is important that we do this together. So data, these are numbers with meaning. So if I just write a list of numbers down, 5, 3, 9, 6, 2, 1, 4, and those are just numbers that I wrote down, those are not data because they don't have any meaning connected to them. Now, if those numbers are how good I was feeling that day, like a rating from 1 to 10, that has meaning associated with it, so it now is data. Or if I measured the heights of students or the ages of students, that's data. And it doesn't actually have to be numbers. Now that I'm thinking about it, it can also be, we can say values is a better way of describing that. So values are just numbers but broader because it can include descriptions and stuff like that. Population is an entire collection of things the data is about. So in that previous example, if I'm talking about heights of students, then all of the students that I'm talking about, that's the population. So if I wanted to just find what's the average height of a 12th grader, my population would be all of the 12th graders that exist. If I wanted to say the average height of an IGA student, it would be all of the students at IGA. If I wanted to say the average height of a 12th grade IGA student, the population would be all of the 12th grade IGA students. So populations don't have to be all of such objects that exist, but they're all of the ones that we're concerned about with here. A sample is a partial collection of a population. So this matters if, for example, we wanted to talk about all the people in the world. We can't ask every single person in the world the question. So instead, we take a sample of the people in the world, and if we do that carefully and do that correctly, we can say, okay, this sample is representative of the world, so whatever we see here will also be true of the world. Now that we get into the actual data itself, a variable is a piece of information about an individual. And an individual, I think I missed that on my slides here. Yeah, so we also want to add in an individual. And that is a single thing from the population. So if you've got a population, whatever the population is composed of, one of those is considered an individual. Okay, so back to variables. A variable is any piece of information about an individual. That includes quantitative variables, which are observations with numbers that measure amount. So we'll talk about this in contrast with the next one, which are categorical variables, which are observations that sort into categories. So an example of a quantitative variable would be heights. Those measure amount, like how much height something has. That's something we can measure with a number that tells us an amount. A categorical variable might be color. Is it blue or is it red? Categorical variables can use numbers. So for example, grade level, like what grade is someone in? That uses a number. They're in 11th grade, they're in 12th grade. But that's not really measuring an amount of something. A 12th grader is not 12 elevenths of an 11th grader. Whereas something that's two times, something that's, let me rephrase that, something that is 2 meters long is twice as large as something 1 meter long. A 12th grader is not twice the student of a 6th grader. So in that case, there is a number being used, but it's just being used to sort. Likewise, we can have quantitative variables that might feel like categorical variables as well. So for example, if I can assign a number to the brightness of the color, like a bright blue versus a dark blue, and I assign that by numbers like 1 to 5, that could be considered a quantitative variable. If, for example, the 5 measure color is 5 times as bright as the 1 measure color, or 5 times as saturated, or something like that. So what you want to think about to kind of differentiate these two is for quantitative variables, if the number, like if something is twice as, like the number is 2 times another number, is it twice as something that we care about? If so, it's probably quantitative. If not, it's probably categorical. If there's no numbers involved, it kind of by default is categorical. All right, and then lastly, we have distribution, and this is the arrangement of values for a variable. So in a population or sample. So back to that height example, if almost everyone's the same height, we'd say it has a very flat distribution. If there's a lot of really tall people and not a lot of short people, if everyone is the same height, that's not a flat distribution, that's a very spiked distribution because almost everyone has the same height. So if we imagine all of our heights, everyone's stacked up in one place. If there's an even number of people at all heights, then that would be a very even distribution. If most of the people are tall, but there are some shorter people, then we'd say that's a skewed distribution. Most of the values are at the tall end. And we'll spend kind of the whole rest of this unit kind of talking about distributions. So if it doesn't quite make sense, give it a day or two, and hopefully that will start kind of locking things into place.